So we saw how many types of ways are there to name a compound. There are some common names known. There are some names which we can identify using the root name, or we can make use of rules and regulations of IUPAC. This was about nomenclature. Now we come to some chemical properties of organic compounds. What are chemical properties? Till now we were seeing how to name it, what are the various types of alkanes, alkenes, alkynes. But if they start reacting, how will they react? This is what we are going to learn in chemical properties. Chemical properties of organic compounds. We are going to see basically three major types of chemical reactions in this chapter. First, which we are going to see, is combustion. Second type we are going to see is addition reaction. Third type we are going to see is substitution reaction. So three chemical properties we are going to observe, or we are going to study. First is combustion. What is combustion? Combustion is anything which burns, is combustion. If I just burn a piece of paper, it will burn with flames, it is combustion. If I burn wood in the air, it is combustion. So in short, anything which burns is combustion. So if I am talking about combustion of organic compounds, what can be formed as a product? Hydrocarbons are made up of carbon and hydrogen. Now imagine if carbon is burning in air, hydrogen is burning in air, what can be formed? There are only two products which is possible in combustion. The combustion examples we can say, most easiest is CH4, that is called as methane gas, or in commonly we know it as a natural gas. This methane, if I heat in air, it reacts with oxygen of the air, correct? We are providing heat to it, it is reacting with oxygen of the air. Now anything which burns, if I take a paper, I burn it. What will you see? When it burns, it produces light. And when I take my hand near the burning paper, it is giving out heat. That means when any substance burns, it gives out heat and light also along with some product. So here hydrocarbons which we are taking is methane. This methane is reacting with oxygen. It forms carbon dioxide plus water plus heat and plus light. Why I am writing heat and light along in the reaction? Because large amount of heat is produced, large amount of light is produced when any organic compound is burned. This is a simple example of combustion of organic compounds. Now if I take a higher compound, let's take butane C4H10. I am taking an alkane with more number of carbon atoms, more number of hydrogen atoms, and I am heating in air. Now what will happen? As I said, all organic compounds which are hydrocarbons will react with oxygen, and here any hydrocarbon which contains C and H will convert into carbon dioxide and water only with heat and light. So this is the reaction of combustion of organic compounds. I have written the reaction, but I have not balanced it. Now it is you who have to balance as you have learned. Just try it and I will write the answer. Two and 2. Let's see, check. 1 carbon, total 4 hydrogen, 2 into 2, 4 hydrogen, here 2 into 2, 4 oxygen, here 2 and here 2, 4 oxygen. This is how we are balancing it. Second reaction, just try to balance it. 2, 10, 13, 2 to the 4, 13, 8. This is how you will balance. See, 4, 2 4s are 8, 8 I have written. Hydrogen 10 into 2 is 20, 10 into 2 is 20, 13 to the 26, here 10 and here 16, so 26. This is how we balance a chemical reaction. This was about combustion. Now out of saturated and unsaturated compound, which compound do you think is burning with a blue flame? Saturated and unsaturated. If I take two type of compounds and if I ask you which will give a blue flame and which will give a yellow flame, what can you tell me? Yes, saturated compounds contain single bonds. Yes, and therefore they do not have too much polluted air or they do not have too much pollutants, and it's easy to break this single bonds, and they burn with a blue flame. Now where do we see such blue flame? At homes. We see at homes while cooking, we see that the gas which is used or natural gas which is used, it's burning with the blue flame. But if sometimes I see the vessel becoming black in color, that time you should understand that lot of impurities are there or lot of unburned carbon is there in the holes which is allowing the air to come, and that needs cleaning. So this is about the saturated compound which gives a blue flame, and this is unsaturated compound which gives a yellow flame. Now why yellow flame is coming out of unsaturated compound? Because there are large number of unburnt carbon. Unburnt carbon, our number of unburnt carbon is present, which does not allow the complete combustion of that the unsaturated compound. So unburnt carbon is formed due to incomplete combustion. What is incomplete combustion? That means where the combustion process or where this process of conversion of whole hydrocarbon into carbon dioxide is not taking place. There are some carbon atoms which are unburned, and that is why it is giving a yellow flame. And when it gives a blue flame, saturated will give a blue flame, that means complete combustion is taking place. Complete combustion of fuel is taking place. So saturated hydrocarbons burn with a blue flame, unsaturated hydrocarbons burn with a yellow flame. Now if I say petrol, diesel, these are unsaturated hydrocarbons, why do they give out so many pollutants in air? Petrol and diesel, they give out too much pollution. Now why do they give out so much pollutants in air? This petrol and these diesel are unsaturated compounds. They contain nitrogen and sulfur also in their constituent as the constituents. Now when the carbon is burning, nitrogen is also burning. This nitrogen when burns, it reacts with air forming nitrogen dioxide. Sulfur is also present in diesel and petrol, that also burns and produces sulfur dioxide. So these are added in the atmosphere as pollutants. So oxides of nitrogen and sulfur are the actually pollutants in air. And therefore we see that the vehicles which are using petrol and diesel are producing large amount of pollution in the air as compared to vehicles which are using CNG. Now CNG is compressed natural gas, And natural gas, what I told you, CH4 is a natural gas, it is a saturated compound. And petrol and diesel are unsaturated compound. Incomplete combustion is happening, and it also contains nitrogen and sulfur. When nitrogen and sulfur reacts with oxygen, it forms oxides, and these oxides are adding in the air as pollutants. And that is why this combustion can be of two types: complete combustion and incomplete combustion. Now we saw what is combustion. Let's go to the second type of reaction, which is called as addition reaction. Now this addition reaction, here the two types of molecules react to form one product. So we can say two molecules react to form one product. And second important thing, it is happening, it occurs only in, it can happen in only in unsaturated compounds. Now, first point, two molecules react to form one product. Addition reaction. Something is added to one. Now suppose I have a compound, another thing is added and it is forming one compound. So that is the meaning of this, two molecules react to form one product. Second, it does not happen in saturated compound. It happens in unsaturated compounds. Now what is unsaturated? Which contains double bond or triple bond. So the compounds which contain double bond or triple bond, in that we see the addition reaction. Let's take an example. Now, first example, C2H4. Now, what is this? This is a ethene. Ethene. Let's react it with bromine. What I have done? I am only showing you with the help of a formula. Later on, I am going to show how the structural formula will change. C2H4, ethene. Ethene contains double bond. ENE is a double bond. I am reacting with another molecule of bromine. What is the product? C2H4Br2. This is the product form. How first characteristic, two molecules react to form one product. One molecule of ethene, one molecule of bromine, they form a compound which is C2H4Br2. I am not naming it now. Let's see how the structure formula shows. Now let's take the structure of this C2H4. That means two carbons. Let's draw 1 and 2. Now since it is a ethene, that means double bond will be present. Let's put here double bond. Okay. Now 4 hydrogen have to be attached. One here, one here, one here, one here. I can attach like this. So 1H, 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 1H. C2, 1, 2, 3, 4, H4. Alright. So this is the structural formula of ethene. Now I am adding it with bromine. I can show bromine like this. One molecule of bromine have 2 atoms. So I am showing it like this. Now when addition takes place, one of the bromine comes and gets attached to this chlorine, and other bromine comes and get attached to this chlorine. Yeah, here the addition is taking place. Now what is happening in that process? This double bond is getting broken, and this double bond is getting broken, and because one bromine is getting attached to this carbon, one bromine is getting attached to the other carbon. Let's see how it will form in the structure. 2 C's, then 1H, 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 1H. This was the original, right? Now after addition, this double bond becomes single bond, and 1 Br come here, 1 Br come here. I can write Br here also, Br here also, H here also, H here also. It doesn't matter if I change the place of Br and H here, Br and H here. Both are possible. Now I have made this. This is the addition reaction. How will you name it? Now, this is the first carbon, this is the second carbon. IUPAC name, how will I name it? Original was ethane, correct? Because we started with ethane, then it became ethene. So original ETH. So first carbon, second carbon. In the first carbon, bromine is added, so I have written 1. Second carbon also, bromine is added, so I have written 2. 1, 2. Now there how many bromine atoms are there? 2. So I can write dibromo. So I can write here dibromo. And what was the root name? It was ethane. Then it became ethene. So root name is ethane. So this is the IUPAC name of a new compound formed after addition reaction. Again see, how many carbons are there? 2. We have to start naming from the right side. This is the first carbon, this is second carbon. At the first carbon, 1 bromine is attached. At the second carbon, second bromine is attached. So while naming it, according to IUPAC, we have to name the carbon atoms. So I will name first as 1, second as 2. How many bromines are present? 2. So 2 is shown as di. So dibromo. What was the root name? Ethane. So 1, 2, dibromo ethane. This ethane part is the root name and this is the prefix. Prefix means before the ethane, before the root word, whichever word is added, it is called as prefix. What is the common name? Common name is ethylene dibromide. It's also called as ethylene dibromide. This is the common name, this is the IUPAC name. After addition reaction, double bond has been broken and single bond is formed between 2 carbon atoms because of the addition of bromine. And the common name is ethylene dibromide and IUPAC name is 1,2-dibromoethane. So we saw how bromine can be added in the addition reaction. Again, one more example I will be showing how hydrogen can add in a unsaturated compound or how to show an addition reaction using hydrogen. Let's take ethane again, C2H4. That means I am using a compound having double bond. This is ethene. I am adding it with hydrogen. Simple. Now what will happen? This hydrogen is getting attached to this compound. Logically, what can be the formula formed? If I am attaching, this hydrogen is attached to 4. 4 plus 2 is 6. So it becomes C2H6. So this is very easy. Can we convert it into structural diagram? Let's see. Two carbons. So I will draw 2 carbons. 4 hydrogen. So 1, 2, 3, 4. Now 1, 2, 3, 4. Each carbon has 1, 2, 3 only. So I will be having one double bond between the 2 carbon atoms because this is a unsaturated compound. I am adding it with hydrogen. A hydrogen can be shown, that means one molecule of hydrogen has 2 atoms of hydrogen. So now what will happen in the addition reaction? One of the hydrogen will go and attach into this carbon. Second hydrogen will go and attach to this carbon. So what will be formed? This double bond will be broken and we will form 2 carbons and 6 hydrogen. 1, 2, 3, 1, 2, 3. So this is ethane. This is the addition reaction where ethene is getting converted to ethane. Now this reaction takes place only in the presence of large amount of heat and nickel or palladium as catalyst. What is the catalyst? Catalyst is a thing which when added to a reaction, it does not take part in a reaction, but it increases the speed of the reaction. So this reaction of addition reaction speeds up if I put nickel or palladium as a catalyst and I provide heat to it. This ethene changes to ethane by breaking of this double bond. This reaction is also called as hydrogenation reaction. This is also called as hydrogenation reaction because hydrogen is getting attached or added to the compound. So this is also called as, this reaction is also called as hydrogenation reaction. Where it is used? It is used in converting vegetable oil to ghee. Vegetable ghee. Now whatever ghee is available in the market, which we know as dalda also, that is converted from vegetable oil to vegetable ghee using the process which is called as hydrogenation reaction. And this hydrogenation reaction is nothing but addition of hydrogen to ethene, where double bond is broken and converted into single bond. That means unsaturated compound is converted to saturated compound. This is called as addition reaction, and we have seen the two major characteristic features of addition reaction. We saw till now two types of reactions or chemical properties of organic compound. We saw two types, combustion and addition reaction. The third type is called substitution reaction. What is substitution? Now substitution means taking place of something else. Now in your school you have seen, if your teacher is absent, what happens? Some other teacher comes and teaches you or sit in your class. That means she is substituting for your original teacher. Same way here, substitution reaction means any atom or a group of atoms are replaced by some another atom or group of atoms. That is called as substitution reaction. This is possible only in saturated compound. In saturated compounds only we see this substitution reaction. Let's take an example of simple methane. Now this methane reacts in the presence of sunlight with the chlorine part present in the atmosphere. What is chlorine? Chlorine is an halogen. They are present in the atmosphere. So in the presence of sunlight, if methane reacts with chlorine in the presence of sunlight, UV rays of sunlight actually are required. Now what will replace what? CH4 is methane, Cl2 is chlorine. Now here one H is replaced by one Cl. So how will I show? CH3Cl plus HCl. How will I show with the structure formula? Let's see, 1C4H. So I will draw like this, right? Then I will draw 2Cl. That means one molecule of chlorine has two atoms of chlorine. What is happening? This chlorine is replacing hydrogen. So I can show you 1C having 3 hydrogen and here 1 chlorine. So CH3 Cl can be shown this way and one H is removed, one Cl is still left. So it will form HCl. This is how a substitution is taking place. That means the chlorine is taking, one chlorine atom is taking the place of one hydrogen atom of methane. This is one example. Second example I can show by CH3 CH2I. Now what is I here? I is iodine. It can also be written as H5I. Right, this is the formula, this is the condensed formula. Condensed formula always show how carbon is attached to hydrogen. So this gives us an idea how the structure will be present. If I react with a base, so say KOH, a potassium hydroxide, now what will replace what? Can you make out? This ion, this will replace iodine. That means the OH group is going to replace iodine. Substitution of iodine by KOH. So let's write CH3 CH2 OH plus Ki. So this is another type of substitution reaction. This can be written as C2H5OH. So these two examples shows how one atom can replace or substitute another atom in a compound. These two are the examples of substitution reaction.